So now we will talk about some special matrices. So let us first see what are triangular matrices. So in triangular matrix, we have upper triangular and lower triangular matrix. UTM. So what is an upper triangular matrix? So square matrix whose non-zero entries are only on the main diagonal or above it. Non-zero entries are only on the main diagonal and above it. All entries below main diagonal must be zero. That is a upper triangular matrix. For example, let's say so this is the main diagonal. So it's a 2 cross 2 upper triangular matrix. Non-zero entries are on the main diagonal and above it, and below it, it must be 0. Similarly, we have 3 cross 3 matrix. This is 3 cross 3. Some of the entries may be 0 on main diagonal as well as on upper triangular also. But all the element below the main diagonal, that must be 0. So it's a upper triangular matrix. Some of the element may be 0, like here it is 0. Some of the element may be 0, but all the element below main diagonal must be 0. So that is an example of upper triangular matrix. So here condition is that Aij must be 0 for I greater than j. In general, you will see Aij will be 0 for I greater than 0. In same way, we can define the lower triangular matrix. LTM is for lower triangular matrix. This is lower triangular matrix. Lower triangular matrix. So by same way, you will say that it's a square matrix whose non-zero entries are only on the main diagonal and below it, whereas all the entries above the main diagonal must be 0. So in same way you can define. So I am just giving you example definition you can write. So here let's say it is 2, 1, 3, this is 0. It's a 2 cross 2 lower triangular matrix. All the elements on the main diagonal, non-zero entries are only on the main diagonal and below it, and all the entries below the main above the main diagonal must be 0. So this is an example of lower triangular matrix. Non-zero entries are only on the main diagonal. Non-zero entries are only on the main diagonal and below it, and all the entries above the main diagonal is 0. So in general, you can say Aij will be 0 for I less than j. This is the condition for lower triangular matrix. ठीक है? Next is diagonal matrix. Diagonal matrix. So it's a square matrix where non-zero entries are only on the main diagonal. All the elements below and above main diagonal must be so in a diagonal elements matrix, non-zero entries are only on the main diagonal. For example, if you have, let's say, 2, 1, 5. It's a 3 cross 3 diagonal matrix. So where non-zero entries are only on the main diagonal. All the elements below and above main diagonal must be 0. So that is called as diagonal matrix. It's a 4 cross 4 matrix. Some of the elements on main diagonal may be 0 also. That is also a diagonal matrix. But all the elements below and above must be 0, and non-zero entries are only on the main diagonal. These are the main diagonal elements. Okay? Then we have a scalar matrix. If all the elements of a diagonal matrix are same, where C is non-zero. If all the elements of a diagonal elements are same, for example, let's say if it is C is a semi-scalar where C is non-zero, then it is called scalar matrix. Scalar matrix. For any square matrix A, we can write AS, where S is a scalar matrix, C into A, where scalar matrix S is, let's say I am writing it as 3 cross 3 matrix. I am taking one example. For example, let's say it is C00. I am taking one example of a 3 cross 3 scalar matrix. Similarly, you can have 4 cross 4, 5 cross 5, n cross n scalar matrix. So when all elements are same, let's say C, then you can always verify this condition. AS into SA is just like you are multiplying matrix A by some scalar value. Okay? So you can easily verify if you take one example, just matrix multiplication, you can verify. I am taking matrix A is, let's say this is 2, 3, 2, 2, 3, 2, 5, 1, 4, and you have 2, 1, 6, 3 cross 3 matrix. So let's multiply with S and check this condition. I have taken 3 cross 3 matrix. So S, you have to take a scalar matrix of 3 cross 3. So let's multiply. I think if you multiply AS or SA, that will be given by simply check this value: 2C, 3C, 2C, 5C, C, 4C, 2C, C, and 6. चेक करो. ठीक है. So you can easily verify by multiplying A and S. चलो. Now we will see unit matrix or that is also called as identity matrix. Identity matrix. If all the elements of a scalar matrix are 1, that is C is equal to 1, then it's a unit matrix or identity matrix. So identity matrix are of different size. So 2 cross 2 I will represent it by I2. 1 0 0 1. This is 2 cross 2 identity matrix. If you have 3 cross 3 identity matrix, so that will be given by 1 0 0 0 1 0, and this is 0 0, and so on. You can define I3 I4, I3 I4 IN, n cross n identity matrix. ठीक है. What will be trace of IN? Trace of IN is sum of diagonal elements. 1 1 1 n times, so you will get n. ठीक है. Now we will see some special real matrices. Special real matrices and that is we will talk about symmetric matrix. Symmetric matrix. What is a symmetric matrix? Let A be a square matrix. Square matrix. So if A transpose is A, if transpose of the matrix is same as matrix A, then it is called as symmetric matrix. This is condition for symmetric matrix. So what will be the condition? You will see, you know that AJI must be equal to AI. AJI must be AIJ. So you can take some examples. Matrix A. So if you have, let's say, 5, 3, 2, 2. So that is symmetrically placed about main diagonal. Another matrix is 1, 3, 5, 3, 2, 6. And what will be this? क्या होगा? This is 5 and this will be 6 and let's say 4. So you will see A transpose is A. So that is a symmetric matrix. So this is symmetric matrix. Then you have a skew-symmetric matrix. Skew-symmetric matrix. So in this case, if A transpose is minus A, if this condition satisfies, then it's a skew-symmetric matrix. And what will be the condition in this case? Aj should be minus of Aij. So in this case, for I equal to j, what you will get? Aii is minus of Aii. So that will give you 2 Aii is 0 or Aii will be 0. So main diagonal element must be 0. In a skew-symmetric matrix, main diagonal elements are 0. This is the condition. Yes, A transpose is minus of A. So in a skew-symmetric matrix, main diagonal element must be 0. So you can check from this condition. So example is, I am taking one example of a 3 cross 3 matrix. So main diagonal element must be, so let's say this is 0, 9, minus 12. So this will be minus 9, can take 0, and this is 20. Then you have 12, minus 20, and this is 0. So main diagonal elements are 0, and you can check that A transpose is minus of A. Okay? Now you should note one point here. Any square matrix can be written as sum of symmetric matrix R and a skew-symmetric matrix S. Any square matrix can be written as sum of symmetric matrix and skew-symmetric matrix. So how to define this symmetric matrix? R is given by, if A is a square matrix, so that is given by A plus A transpose. and skew-symmetric matrix is given by half A minus A transpose. Then you can always check that A is equal to, A is our square matrix, A is R plus. So any square matrix can be represented as sum of symmetric matrix and skew-symmetric matrix. Why R is symmetric? So because you can find R transpose will be what? Half A plus A transpose whole transpose. So this is half A transpose plus, and this will be half A transpose plus A, and that will be same as, so R transpose is R and S transpose is half A minus A transpose whole transpose. So that is half A transpose minus A transpose. So that is half A transpose minus A, and this will be minus of S. So R is called as symmetric part of A. It's a symmetric part of A. Sometime in exam they may ask you what will be the, if A is given, what is the symmetric part of A? So that is you have to find this value. And S is the skew-symmetric part. S is skew-symmetric part of A. Clear? So let's take one example. You have, let A is a square matrix, example of symmetric, and let A is a square matrix, and you have to write their symmetric and skew-symmetric part. So this is 3 minus 4 minus 1, then you have 6, 0 minus 1, this is minus 3, 13 and minus 4. It's a square matrix, 3 cross 3, write down their symmetric part and their skew-symmetric part. So for symmetric part, this is A. So what will be, you have to find its A transpose. What will be A transpose here? So this will be given by 3 minus 4 minus 1, 6, 0 minus 1, minus 3, 13 and minus 4. So if you know A and A transpose, you will get this symmetric part. Symmetric part is half A plus A transpose. Write down this matrix. So 3 plus 3 is 6 by 2. This is 3. Minus 4 plus 6, 2. This will be 1. Minus 4 and this will be minus of 2. Then 6 minus 4, 2. This is 1. Then 0 plus 0. Minus 1, this is 6. 12 by 2 is 6. Minus 3 minus 4 by 2, minus 2. 12, this is 6. Minus 8, this will be minus of 4. So this is the symmetric part. Three plus 3 is 6 divided by 2. So this will be 3. Yes, this will be 3. You can take it as 3. First element is 3. Then skew symmetric part is half A minus A transpose. This matrix is given by, so this is A minus of A transpose, so 3 minus 3, this will be 0, minus 6, minus 4, minus 6, minus 10, this is minus 5, then minus 4, minus 2, this will be minus 2, plus of plus 2.
1 divided by 2.
So this is A minus of A transpose. So minus 1 plus 3. Plus 3 divided by 2, this is plus of 1. Yes. So this will be plus of 1. What about this term? 10 by 2 is 5. Next is 0 minus of 7. Next is minus 1, 7, and now you can check that A will be simply R plus. Okay. Next is we have orthogonal matrix. What is an orthogonal matrix? Again, A is a square matrix. Aij n cross n is a square matrix. It's a square matrix. So if A transpose A is an identity matrix, A transpose, or that will be A into A transpose is identity. A transpose is identity. And this also implies if A transpose is A inverse of a matrix. We will define inverse of a matrix. Till now I haven't defined inverse of a matrix, but you should just remember the definition that A transpose is A inverse. So at this stage, at least we can check this. A transpose A should be identity matrix. Then A is an orthogonal matrix. Okay? For example, I am taking this example. Cos theta, let's take this example, cos theta minus sin theta, and this is sin theta. So what will be A transpose? A transpose will be cos theta minus sin theta, and then you will get, this is sin theta cos theta. Now check this condition. What will be A transpose? A transpose. A transpose. So this will be a row by column. So cos square theta plus sin square theta, that will be 1. This is cos theta sin theta minus, so this will be 0. Then you have row by column. This is also 0 and this will be 1. So that is identity matrix, and that will be same as A transpose A Another example is matrix A is given by this matrix is 2 by 3, 1 by 3 and 2 by 3. Then you have minus 2 by 3, 2 by 3, 1 by 3. And then you have 1 by 3, 2 by 3 and minus 2 by 3. This is 2 by 3, minus 2 by 3, 1 by 3. Again, you can verify this condition. So if you verify it, you will get same condition. So you can easily verify that A transpose A is same as A transpose, and that should be equal to 3 cross 3 identity matrix. This is 2 cross 2 identity matrix. So by matrix multiplication, you can easily verify. ठीक है, हो जाएगा ये, so that you can easily verify. Now there is another important point that you have to remember, that in an orthogonal matrix, row or column vectors forms an orthonormal system. Orthonormal system. Forms an orthonormal system. So what is an orthonormal system? Let you have AI dot AJ. This must be chronicle delta, where AI is either row vector or column vector, and this should be 0 if I is not equal to 1, and this is 1 if I is equal to, this is I is not equal to J. That you can verify. Means that satisfies this condition also. Their row and column vector also satisfies this condition. If I take, for example, let A1, so what will be A1 dot A1? That will be 1. So if you take dot product with itself, either you are taking row vector or column vector, both will give you, they forms the orthonormal system. So A1, where A1 is a row vector, I am taking it as a row vector. So you can check if this is first row, so this will be what? This matrix is, this is 2 by 3, 2 by 3, 2 by 3, 1 by 3. Yes, this will be 2 by 3, this is 1 by 3, and this is 2 by 3. So you have to write row by column. ठीक है? So if A1 is a row vector, so this will be what? It means AI dot AJ, how you will define? AI dot AJ. If A is a row vector, then this is given by AI AJ transpose. If row vector, if AI is a row vector. And same thing can be defined AI dot AJ. This will be given by AI transpose AJ if AI is column vector. That is how inner product is defined. That is how inner product is defined, row by column. So that's why A1 dot A1, if you calculate, this will be 2 by 3, 1 by 3, 2 by 3. Just multiply it. So this will be what? 4 by 9 plus 1 by 9 plus 4 by 9, and this will be 1. Single entry. A1 dot A1 will be 1.
First case में AI is row vector.
If you are, I have defined the inner product of vector. So this is written inner product, but when AI is a row vector and this is also a row vector, so what will be their inner product? AI into, in terms of matrix multiplication, this is row by column, so this will remain same row, but this you have to take as a transpose. So you will get row by column, that will give you inner product of these two. But when it is a column vector, so it's a column, so you have to make it as a row, so AI transpose J. That is how inner product is calculated. ठीक है? In same way you can verify this. I am A2 dot A2, this will be 1, A3 dot A3. This may be either row vector or column vector. If it is row vector, inner product is calculated by using this definition. If all are column vector, then you have to take this definition. And you can also check what will be A1 dot A2. A1 dot A2 must be 0. So let's say this is A1 and this is A2. So A1 is a row vector, that is 2 by 3, 1 by 3, 2 by 3. So A2 will be A2 transpose. I am taking this as a row vector. So A2 transpose will be what? Minus 2 by 3, 2 by 3 and 1 by 3. A1 dot A2 minus 2 by 3, 2 by 3 and 1 by 3. So what you will get here? Minus 4 by 9 plus 2 by 9 plus 2 by 9. So this will give you 0. So in an orthogonal matrix, you can also satisfy this condition. Similarly for A1, A3, A2, A3, A1, A3 and also A2, A3. So whether you are taking row vector or you are taking column vector, they forms the orthonormal system. Clear? So A2 dot A3, this will be 0. Now, complex analog of these matrices are, we call it as a complex matrices. So first is, let A be some complex matrix. This is Aij. This is an n cross n matrix. It's a complex matrix. So A star is complex conjugate of this matrix. If A is a complex matrix, so A star represents complex conjugate matrix. So that will be obtained by, you have to take complex conjugate of each element. This is complex conjugate of A. And then we define A dagger, cross sign. So A dagger is given by A complex conjugate transpose. How to find A dagger if complex matrix is given? So A dagger is first find complex conjugate and then take transpose. So that will give you A dagger. So now see, if A dagger is A, then it's a Hermitian matrix. It's a Hermitian matrix. And what will be condition for Hermitian matrix? You will get AJI complex conjugate, because A transpose is this value and this should be equal to AIJ. So if I is equal to J, then this will give you AII's complex conjugate is AII. What does it means? Diagonal elements are real. Diagonal elements are real. Diagonal elements are real. So, for example, in a Hermitian matrix, diagonal elements are always real. So, I am taking this as, so example is, let's say 4, 1 minus 3 iota. This is 1 plus 3 iota, and this will be, let's say 7. So what will be A complex conjugate? So this is 4, 1 plus 3 iota. This is 1 minus complex conjugate. Iota is changed to minus iota, and then that will be 7. And this will give you A dagger. So that is A complex conjugate transpose, and 4, 1 plus 3 iota and 1 minus 3 iota, and that is same as A. So A is a Hermitian matrix. Okay. Now, if A dagger is minus A, if this condition satisfies, then it's a skew Hermitian matrix. Skew Hermitian matrix. It's a skew Hermitian matrix, and in this case, you will get A complex conjugate JI. This should be minus of AIJ. So if I is equal to J, this will give you AII complex conjugate is minus AII. This condition must satisfy. So what does it means? From this, what you will get, let diagonal elements are some complex alpha plus iota beta. So then this condition will tell you A complex conjugate is alpha minus iota beta is minus times alpha plus iota beta, and this will give you alpha minus iota beta is minus alpha minus iota beta. This will cancel out. 2 alpha is 0 or alpha is 0. Alpha is 0. This condition is giving you alpha 0. So when alpha 0, AII is iota beta. So diagonal element, you have to impose this condition. Means AII is pure imaginary or it may be 0 also. So main diagonal elements are pure imaginary or it is 0. Main diagonal elements are pure imaginary or it is 0. So that is a skew Hermitian matrix. So let's take one example of a skew Hermitian. So matrix A is given as, I'm taking it as 3 iota 2 plus iota minus 2 plus iota, and this is minus iota. So main diagonal element, it should be either pure imaginary or it may be 0 also. So in this case, what will be A dagger, A complex conjugate? So minus 3 iota, 2 minus iota, minus 2 minus iota, plus iota. So what will be A dagger? A complex conjugate transpose. So this is minus 3 iota, 2 minus iota, minus 2 minus iota, plus iota. And if you take minus common, what you will get? 3 iota, 2 plus iota, minus 2 plus iota, minus iota. So that will be minus of A. So you can easily check this condition. Whenever A dagger is minus of A, that will be a Hermitian matrix. Skew Hermitian matrix, yes. When A dagger is A, that is Hermitian. When it is minus A, it is skew Hermitian. ठीक है? Now we will see unitary matrix. Unitary matrix. So in this case, if A dagger A is A dagger, and that is identity matrix, then A is a unitary matrix. And this also implies that A dagger is A inverse. If A dagger or A dagger A is identity matrix, then A is a unitary matrix. Also, row and column vectors of A forms an orthonormal system. Orthonormal system. Again, AI dot AJ is chronicle delta. But how to we have defined the inner product for real matrix. For complex matrix, let AI and AJ be a column matrix. They are the complex matrix. So in that case, inner product AI dot AJ is given by, this is AI complex conjugate transpose AJ. This will be canonical unit. How to find it? Row by column. But because it's a complex matrix, so you have to, and it's a column, so you have to convert into row, but you have to take complex conjugate transpose. That will define its inner product. So if you have a unitary matrix, their inner product must be, this must be delta Ij. They forms the orthonormal system. But how to define inner product? This is the case. If they are row vectors, then this will be complex conjugate transpose, because you have to multiply row by column only. You have to always write row by column. If they are row matrix, so then because it's a row matrix, so row by column, first will be same matrix, this will be transpose because it's a row by column. Clear? How you will find the inner product of complex matrix? For example, matrix A is given as, this is iota by 2 under root 3 by 2, and this is root 3 by 2 and iota by 2. First you should check that this will be a, what will be complex conjugate? Minus iota by 2 under root 3 by 2 under root 3 by 2, and this will be minus iota by 2. Then you will get A dagger is A complex conjugate transpose. So this will be minus iota by 2 so let's multiply this A dagger. What you will get? This is iota square is minus 1. You have to take iota square is minus 1. So this will give you what? 1 by 4, and this is 3 by 4. So 1 by 4 plus 3 by 4. And this will be 0. Iota under root 3 by 4 minus iota. So this will be 0. Row by column, this will be also 0. Row by column. So this will be 3 by 4 plus 1 by 4. 3 by 4 plus 1 by 4. So that will be an identity matrix. That will be an identity matrix. And that should be equal to A dagger A. A dagger A. So this is 2 cross 2 identity matrix. If you want to check this, so here I am replacing by column vector. So let's say A1 is a column vector. So A1 will be given by what? Iota by 2 under root 3 by 2. A2 is another column vector under root 3 by 2 and iota by 2. So this is, so what will be A1 dot A2? A1 dot A2. So that is A1 complex conjugate transpose A2. So this becomes minus iota by 2 under root 3 by 2, and that should be under root 3 by 2 iota by, so that will be 0. And what will be A1 dot A2? So this is A1 complex conjugate transpose A1. So minus iota by 2 under root 3 by 2, and this will be iota by 2 under root 3 by 2. So you will get single entry. Iota I square is minus 1, so 1 by 4 plus 3 by 4. So this will be 1 cross 1. So they forms an orthonormal system. Similarly, you can verify it for 3 cross 3, 4 cross 4. Any matrix is given, you can check.
A1 dot A1.
Yes, this is A1 dot A1. Please correct it. This is A1 dot A1. Yes, this is A1 dot A1. So A1 dot A1 is 1, A1 dot A2 is 0. ठीक है? Okay. So any doubt up to this point? So these are the basic part. Till now I have just introduced the what are the basic concepts and how to multiply matrices, trace, transposition, and some special matrices. In next lecture, we will see the application part. So how to solve linear system of equations, how to check linear independence, linear dependence of the matrix. So that we will see in next lecture.